Professor Douglas Osheroff is a 1996 Nobel Laureate in Physics from the Department of Physics at Stanford University. He was awarded the Nobel Prize for his discovery of superfluidity in the isotope helium-3. Professor Osheroff noticed a jump in the heat capacity of the liquid helium-3, indicating the conditions required for helium-3 to change from an ordinary liquid to a superfluid. His discovery sparked intensive research into superfluid helium-3 and other so-called quantum liquids, as it enabled scientists to study the types of quantum mechanical effects in large, visible systems that could previously only be studied at the atomic and subatomic level. Professor Osheroff's work was considered a breakthrough in low-temperature physics, and in the course of his research on helium-3, he developed an early form of magnetic resonance imaging, but only in one spatial dimension.
Hello and welcome to this special edition of Talk Vietnam for an exclusive interview with 1996 Nobel Laureate in Physics, Professor Douglas Osheroff from Stanford University. It's our honor and privilege to have him here with us. Today we will learn about the discovery that won him the Nobel Prize, as well as how science changes our lives. Hi, Professor Osheroff. How are you today?
Fine.
How was your trip to Vietnam? Is this your first time?
First time to Vietnam,
Yeah.
but we actually went to Thailand first before coming here. So by the time I got here, no jet lag anymore.
Excellent. So what was your first impression of Vietnam upon your arrival?
Well, it was interesting. I mean, I didn't know what to think about it because I was just very happy I hadn't gone to Vietnam earlier, AKA during the war, the American War.
So what made you decide to donate your precious time and energy to the 4th ASEAN event series, Bridges, Dialogues Towards a Culture of Peace?
Uwe invited me. I'm very bad at saying no, but it seemed to me that it was a really valuable and interesting program and something that I would enjoy. You know, I do a lot of this. I particularly enjoy. I've actually brought demonstration lectures to first grade classes.
Wow.
Yeah, so mostly, you know, if I'm doing demo stuff, it's in the United States because it's kind of hard to get all that stuff overseas. But you know, I think, you know, science is fun, and I like to share that with other people.
Excellent. Upon his arrival to Hanoi this time, Professor Osheroff joined a press briefing at the Hanoi Hilton Opera. Let's have a look.
Hanoi is the second destination after Bangkok for Professor Osheroff on his tour for the 4th ASEAN event series, Bridges, Dialogues Toward a Culture of Peace, organized by the International Peace Foundation and the Vietnamese Ministry of Education and Training. The event drew great attention from the Vietnamese mass media.
I really think that what this exercise for me is all about is sharing my excitement toward science and try to explain to you how science indeed is discovered, new science, and how we can use that science to improve the lives of all of us.
To be able to invite them to Vietnam, the organizers had to contact the guest scientists 2 years in advance. Visits like these benefit Vietnam in many ways, according to the planners.
These are not one-time visits only, but visits with many fruitful returns. We want them to become somehow ambassadors of Vietnam, goodwill ambassadors, and also tell about their good experience here when they go back to the United States or to Europe, what they have learned here from Vietnam. We want them also not only to speak, not only to talk, but also to listen, to learn more about Vietnam, and to see how they can be of benefit for the development of the country in the long run.
Members of the audience asked Professor Osheroff many questions at the event. The answers he provided satisfied Vietnamese journalists, including Lê Thành Y.
I think it really will behoove.
Giáo sư đã đề ra một vấn đề như thế này. Chúng ta phải tăng cường đưa các bạn trẻ đi học mà theo các hợp đồng, mà thậm chí này các bạn trẻ đủ trình độ và điều kiện giúp được các giáo sư thì người ta sẽ trao thêm tiền, trả công cho họ trong những cái việc họ hợp tác làm ăn. Cho nên tôi cho rằng đây là một cái hướng mới mà có lẽ mình cũng nên chấp thời cơ.
Right after the press conference, Professor Osheroff restarted his hectic schedule of meetings with Vietnamese policymakers, lecturers, and Vietnamese physicists and students.
You were always interested in science from a young age, and your parents had a great influence, and they facilitated that interest of yours. Can you tell me a little bit about their influence on you when you were a young child?
Well, I guess I was, I think, 6 years old when I got an electric train for Christmas. It was a typical toy, but by the end of Christmas Day, I'd taken the locomotive apart to get the electric motor out.
Excellent.
And this was a watershed moment. I think if my parents said, "You destructive devil, go to bed without your supper," we wouldn't be having this conversation now. But my parents, particularly my father, was fascinated with my fascination for mainly electricity and magnetism.
In an interview, you once said that you may have have been a danger to your family as a child, since you had an interest in gunpowder and high voltage electricity. Can you tell me a little bit about that?
Well, yeah, the gunpowder, I don't think that was too much of a danger, but I like to blow things up. It's true. High voltage electricity, I think I probably, there was one time I charged a bank of capacitors, which I'd gotten. My father had a patient. He was a medical doctor, my father was, and he had a patient that worked for the telephone company, and he would bring stuff to my father to give to me, and I could generally find ways of making that stuff nearly lethal. So I had a bunch of capacitors, and I charged them all up to 600 volts, and then, mistakenly I discharged the capacitors across my body, and the next thing I knew, I woke up on the other side of the room, and I had no recollection of being shocked by this thing. It just, it was one of these things. So,
wow.
I probably was kind of dangerous.
You're a Nobel Laureate today, but back in the day in school, were you the best in your class?
Well, when I was actually a slow reader. In fact, I still am. So I think in first grade, I probably didn't look very smart, but probably by sixth grade, I looked pretty smart, and I think after that, I was usually #1 in my class. But
Excellent. So, where were you when you received the news that you had won the Nobel Prize back in 1996?
Well, so I was in bed asleep. The call came at 2:30 in the morning.
Oh, wow.
And so the phone rang. Now, the phone is on my wife's side of the bed, but she never picks it up. So I jumped out of bed, ran around, picked up the phone. I said, "Hello?" And the person on the other end said, "Hello, hello, is this Douglas Osheroff?" I said, "Yes, it's 2:30 in the morning." And he said, "I know that, but I have a matter of some importance, if you will. I am Carl Osheroff, Secretary General of the Royal Swedish Academy of Sciences." And in that moment, of course, my jaw drops down to my navel because I know exactly what this phone call is about. And so he tells me that I'm getting the Nobel Prize and who I'm sharing the prize with, and which was good. That was kind of important because there were two professors that basically trained me and provided the research capabilities and everything. Anyway.
So what did you do right after you got that phone call?
Well, I felt that my life was changing, and it was one of these moments that really a watershed moment in my life, and I think I understood pretty well that it was things were going to be different after that.
In the 1930s, another strange phenomenon was observed. This rapidly evaporating liquid helium cools until at 2 degrees above absolute zero, a dramatic transformation takes place.
Suddenly, you see that the bubbling stops and that the surface of the liquid helium is completely still. The temperature is actually being lowered even further now, but nothing particular is happening. Well, this is really one of the great phenomena in 20th century physics.
The liquid helium had turned into a superfluid, which displays some really odd properties. Ordinarily, this container with tiny pores can hold liquid helium. But the moment the helium turns superfluid, it leaks through. Superfluid helium can do things we might have believed impossible. It appears to defy gravity. A thin film can climb walls and escape its container. This is because a superfluid has zero viscosity. It can even produce a frictionless fountain, one that never stops flowing. Superfluidity and superconductivity were baffling concepts for scientists. New radical theories were needed to explain them.
So what actually triggered your co-discovery of superfluidity in helium-3?
I thought we were going to be studying solid helium-3, and in fact there were two people in the research group, two graduate students that were doing rather similar experiments. But the technique that we used to get cold involved the solidification of liquid helium-3. So we had a mixture of liquid and solid helium-3 in the cell. And I was I was basically converting liquid to solid at a constant rate, and the pressure was rising as it should if things were getting cold. And then all of a sudden there was a very sharp decrease in the rate of cooling. And I, of course, thought that was terrible. And that was the signature of superfluidity in helium-3, actually.
Do you think that luck may have had a role, though tiny, in all those landmark discoveries made by you and other Nobel laureates?
Well, you know, what I say is that bright people manufacture their own luck, you know, by being at the right place at the right time, doing something different that no one's done before, and developing technologies that allow you to probe nature in a new and different realm.
Looking back at your career path so far, do you think it was a tough one? And what was the greatest challenge that you have faced?
I don't think it was tough. It was something I, you know, always enjoyed doing. I guess, you know, the 4 years at Caltech were the hardest. Okay, I mean, the Caltech was really tough, and you know, I took physics from Richard Feynman, who was kind of my freshman class started out 192 students, and the beginning of the second year, only 120 returned. So that gives you some idea what it's about. But for me, it was fantastic, but it was a lot of work. I mean, you know, I think I think people that don't challenge themselves don't go anywhere, right?
That's true. Very true. So after graduating from Caltech, you went on to Cornell University in 1967. During that time, you and your colleagues, David Lee and Robert Richardson, made the discovery that later brought you the Nobel Prize. Can you tell me a little bit more about those years?
Well, so I came to Cornell, and the first semester, you know, I was a new graduate student. I wasn't attached to a research group yet, although I was teaching for Dave Lee, so he knew who I was. And eventually I got into the low temperature group, and because, you know, there were two talks actually that first semester when I was there on low temperature physics, and it looked to me like this would allow me to look at nature in a new and different realm, and that's why I went into low temperature physics. And so I started, it was a magical time, because there were these new refrigeration technologies that were just being developed, and I was kind of
excited.
Part of that, So at first it was a matter of getting cold and maintaining very low temperatures. I mean, we could get down to a fraction of a thousandth of a degree above absolute zero. And then I was doing this experiment, which was really mostly testing out the technology. And everything was cooling very nicely, and then all of a sudden there was a rather sharp decrease in the rate of cooling, and of course, I was very unhappy to see that, but that was the signature of superfluidity in helium-3.
So you shared the Nobel Prize with Lee and Richardson, who were both senior researchers at that time, while you were a graduate student. That probably doesn't happen very often, does it?
I don't know. I mean, I think for me it seemed quite natural, and it's funny that the Nobel Prize was split 3 ways, and so I got only a third. But the Nobel Prize is not about money. It's fame and glory, I suppose.
How do you think you could emerge so rapidly and so successfully? What led to that?
Well, I must say that after discovering superfluid helium-3, of course, I immediately focused in on that and did what when you discover a new phenomenon or new field, the thing you want to do is skim all what they call it, skimming the cream off the top. You do all the good experiments first. So I tried to do as many of those as I could, and it was amazing because, well, of course, very shortly after the discovery, I moved to AT&T Bell Laboratories. Now, the bad part about that was that I had to start all over again, building up a new laboratory.
Yeah.
But Bell Laboratories was very generous to me, very supportive of my research. And so I had a technician, but in fact, the technician only took one set of data for me in the many years that I was at Bell Labs. I never understood that data. So I would basically farm my technician out to other people.
Yeah.
And I thought that was a good use of his time, and I was happier working by myself.
Yeah. So how has your Nobel Prize winning discovery been applied so far?
Well, superfluid helium-3 was, I guess, to use a technical term, the first unconventional BCS state. Now, BCS stands for Bardeen, Cooper, and Schrieffer. They were the 3 people that explained the microscopic origins of superconductivity in metals, obviously. And superfluid in helium-3 was, in fact, a broad generalization of that theory, but where there was very different, because in the case of a superconductor, the attractive interaction that leads to the formation of Cooper pairs, they're the entities that really condense, was through the lattice. Superfluid helium-3 has no lattice. It's all a liquid. And so it was really very different system, and it was, man, I had really world-class theorists that were popping their heads in my lab every day asking me what was the news and stuff like that.
During his visit to Vietnam this time, Professor Osheroff visited the Hanoi National University, where he lectured on how science changes our lives. Let's take a look.
The conference hall of the National University of Vietnam today is full, since every student wants to see with their own eyes a Nobel Laureate. A ceremony was held today to commemorate the honorary doctorate that the president of the university presented to Professor Osheroff, the second time such an honor has been given to a Nobel Laureate.
Thông qua việc vinh danh những nhà khoa học xuất sắc có cống hiến lớn lao cho nhân loại như giáo sư Osheroff và các nhà giải thưởng Nobel khác, thì cả những nhà khoa học xuất sắc thế giới và chúng ta hiểu biết lẫn nhau hơn, và như vậy thì cái cầu nối, cái hợp tác giữa Đại học Hà Nội với Đại học Stanford, nơi giáo sư Osheroff làm việc, cũng như với các trường đại học Hoa Kỳ khác và các cái tổ chức khác nói chung sẽ được phát triển.
Nguyễn Đức Hoài is among the lucky few who met and talked with Professor Osheroff during his previous seminars abroad. Meeting him again in Vietnam reminds Hoài of earlier events.
Trước đây trước khi gặp giáo sư thì tôi nghĩ rằng ông Osheroff là một ông rất là nghiêm khắc và rất là kỹ tính, bởi vì chúng tôi đã gặp rất nhiều nhà khoa học và họ có những cái nguyên tắc, nhưng mà đối với ông Osheroff thì cái cảm nghĩ ban đầu về một cái nhà khoa học mà rất là thân thiện và gần gũi, và ông ấy có thể chia sẻ cùng uống một cốc nước trà và chia sẻ tất cả các câu chuyện cho chúng ta.
On these rare occasions, meeting with a Nobel laureate, students ask the professor many questions. The questions could be about the scientist himself, his research method, or which area they should focus on in the future.
Biggest wishes. I don't know what to tell you, but in fact, it's I think you have to, at some level, if you're doing basic science, you, part of the joy of doing basic science is answering questions that no one knows the answers to, and there's a lot of joy involved in that. But in fact, I think if you want to maybe better mankind's position on, you know, you can come up with new technologies and things. That's not basic science anymore. That's really applied science, and I would dare say that I think there's a lot of applied science that is very useful, very enjoyable to do, and in fact, I think you don't have to worry whether something you're doing, such as maybe superfluidity helium-3, actually will ever be useful for mankind. So I think it's a decision that you have to make.
Cũng như lúc nãy em đã đặt câu hỏi cho giáo sư thì hiện tại bọn em ở trường Trung học phổ thông chuyên khoa học tự nhiên cũng đang có một câu lạc bộ khoa học. Em rất mong muốn là nhờ những buổi nói chuyện như giáo sư ngày hôm nay thì các bạn học sinh sẽ có thể được tiếp lửa niềm đam mê và có thể biết đâu sau này thì sẽ có ai đó đạt giải Nobel chẳng hạn.
Em thích cái câu là đừng bỏ cuộc khi gặp những điều khó khăn trong cuộc sống. Thì nó cho em một nỗ lực để tiếp tục cố gắng trong học tập và theo sự nghiệp sau này.
Winning a Nobel Prize is the wildest dream for students of science here today. But who knows if someone can attain something great thanks to this talk? That fact will only be known in the future.
You had a lecture at the Hanoi National University here in Vietnam. You spoke about how science changes our lives. Yeah. How does it actually happen? How does it change our lives?
Well, I mean, take an example. Marconi invents the radio or whatever, radio waves. And that allowed us to communicate a lot faster. And so, you know, people communicate. That's very important stuff, right? And I think it's kind of